Hello everybody, my name is Matt. I'm a university professor in the US, where I run a research lab and teach graduate students and medical students. I recently started a project called Heureka Labs, focused on extracting meaning from data and using those insights to gain information and knowledge, and doing so in an efficient and impactful way. I thought it'd be fun to make a series of videos explaining some of these concepts in data science for people just beginning this journey, where I was not too long ago. In today's video, we're going to define data science and think about a framework in order to understand the process of data science and how to go from data to information. And finally, we will discuss how to think about learning data science. If you're into thinking about learning, this is the meta-learning of data science. Let's begin. Once upon a time, people used pencils and pens and paper in order to plot their data and to find meaning in it. But as the technological revolution catalyzed this boom in information generation, we now struggle to make sense of data and to find the information hiding within it. So then what do we do now with 1 quintillion bytes of data? Where do we find the information within that? Before we dive in how to solve this problem, we first better explain what exactly is data. Well, there's a framework that describes different types of human information, and this is called the DIKW framework, or triangle. The D stands for data. Data are disparate pieces of information that are disconnected from many other things. We can think of financial data, scientific data, data about space or time. These data then are recordings or collections of events. This is how we can think about data. Now, these data usually aren't that helpful because they're disconnected from most other things. Instead, what we want to do is we want to make connections of these data, or we want to identify how some of these data fit with other types of data. And when we do this and we make these connections, this is called information. Now, this is just one step up now on the information triangle. When we move from data into information, we can then start to extract meaning from these data. This information, though, is not useful on its own. What we need to do is we need to make further connections from this information. And when we do this, this is where we now start to develop something we call knowledge. And knowledge is this connected pieces of information that then we can use, that we can that's actionable, that we have now sort of deep within our understanding. The final pinnacle of this triangle is going to be wisdom. Now, how we move from knowledge to wisdom is a matter of deep philosophical debate, so we won't get into it here. But now if we go back down to the bottom of the triangle, what we want to do is we want to ask the question, well, how do we go from data into information? This is exactly where data science comes in. Data science is the process by which we can take raw data, glean insight from it, and convert that into information so that we can then use it to make connections, to have actionable knowledge to move on. All right, now let's get into a little bit of meta-learning about data science. The first step in any learning project is going to be to think about why. Why do you want to do this project? Why do you want to dive into data science? Now, this answer is all on you. I don't have an answer for it. Everybody's answer will be different. The motivation for what you do needs to be really, really clear. Otherwise, you're not setting yourself up for success. Okay, so beyond why, next is what. What you are going to learn. In data science, you're going to be learning 3 different types of things. First are concepts. You need to know the general concepts of data science. These concepts are generally going to be related to computer programming, how to take complex data, march through a defined set of procedures in order to have some outcome, some computed outcome that then you can link back to the data. The second is facts. Facts of data science are going to be the specific things that you need to know in order to do data science. So what does this mean? So these are going to come in the form of the specific commands and codes that you will use in order to transform data. So we start out with some data, and then we do something else to it, and then we do something else to it, and so on. The things that we do to it, those are the facts. Those are the specific pieces of information that you need to know that you're going to be applying to data in order to transform it into information. 3, procedures. These are generally going to be the procedures you will use to transform data into knowledge. In data science, this is generally a computer programming language, knowing the specific commands of how to take your data and transform it into knowledge. This is generally going to be in one of 2 programming languages, R or Python. Now, There's going to be a big debate of whether you should start with R or Python and the merits and differences between the two and so on. But I will argue that it doesn't really matter. The language you use doesn't matter. What you need to do is find a language that resonates with you, that you're excited to learn, and that will allow you to carry out the different skills. Now, if we take another analogy, let's take cooking, for example. It doesn't matter what technique you use to cook. In the end of the day, all that matters is how did the meal taste? Did you use this method or that method, or what procedure? Did you use sous vide or did you grill or so on? It doesn't matter. At the end of the day, you are a chef and you are making a meal. Just like in data science, at the end of the day, you are taking data, you're transforming it to knowledge, and how you do that, what language you use, it doesn't matter in the big picture. What you need to do is just find a language that resonates with you, where you can start and dive right in. The third part of this meta-learning discussion is going to be how. How you are going to actually carry out this process. Well, like anybody beginning their journey, you probably don't know. So what you need to do then is look and see what have other people done. How do other people learn data science? And I will say there are generally a few different ways. First, take a course. Now, this could be a university course, there's online courses, there's plenty of companies that are offering online tutorials that you can pay for that guide you through some steps. This guided process is oftentimes a great place to start. However, just like many other learning processes, you don't want to get into a track and not reassess, is this the right track for me? If you start a course and you realize halfway through that the course is going left and you want to go right, well, you should be confident enough to say, well, I'm going to stop here and I'm going to continue my journey by going this way. And the good thing about data science is there are plenty of tutorials, there are plenty of blog posts, there are plenty of resources on the internet, YouTube videos like this one, that will allow you to continue your data science journey. So there you have it. 3 steps of meta-learning: asking why, asking what, and asking how. And with these in mind with data science, you are now equipped to think about why you want to do this, what are the specific things that you need to learn, and how you will go about learning this. Data science isn't some magical unicorn that's going to come in and solve every single problem you have. It's quite simply some tools that you can learn, if you're motivated, in order to take complex data and extract meaning from it. If you like this video, go ahead, give us a thumbs up. If you want to learn more, hit the subscribe button below. This is just the first video in a series of videos where we'll be exploring some of these key ideas in data science and exploring the tools specifically that you can use in order to master this new skill. Thanks for watching. We'll see you next time.